systems for enhancing human healthcare and human-machine interfaces. So currently I'm an associate professor and usual faculty fellow in mechanical engineering and biomedical engineering at Georgia Tech, and also I'm the director of the IN Center for Human-Centric Interfaces and Engineering. All right, before jumping into my research, let me briefly introduce my group here at Tech. Currently, we have about 40-something people in the group, including 10 postdocs, 2 full-time engineers, and 26 also graduate students. We have a fairly big group. So as a group, we study multiple things. We study materials engineering, nanomanufacturing, system packaging, machine learning, and integration. So based on that fundamental science study, we develop systems as shown over here. So these are examples of our ongoing projects in terms of developing soft biosensors and bioelectronics. So as you see that some examples are targeting wearable applications, and some are designs for implantables. So we work on both domains, but today, due to time limitation, I'm going to focus on some of the wearable technologies that we are working on. So we developed this soft wearable biosystem. Now they can be wearable on the skin to measure various types of non-invasive signals, right, without penetrating tissues. So by gently putting those sensors and electronics onto the skin, we can measure signals as listed here, like biopotentials from our body, like heart, brain, eyes, and so on. And at the same time, we can measure signals like respiration, heart rate, sound, electrodermal activity, hydration, and so on. So once we can measure these high quality electrophysiological signals, then we can do a portable ambulatory health monitoring using those devices. And at the same time, we can offer a quantitative automated disease diagnosis by putting those devices on the skin. And once we have that diagnostic results, then we can integrate our sensor systems with the virtual reality, augmented reality, and others to offer home-based therapeutics, as shown over there, as we publish it in Science Advances. And at the same time, once we can measure high-quality electrical and physiological signals from the body, then basically we can detect users' intentions. Then we can utilize those signals for persistent human-machine interfaces. So we can utilize signals that we can measure from brain, like heart, motions, and things like that. But today, I want to focus on this brain-machine interfaces, where we can measure the signals from the scalp non-invasively, again, by putting sensors over the scalp locations on the skin. And then we measure these signals called EEG, electroencephalograms. And by using those signals, we are trying to control external devices like hardware and software. But today I only have, I guess, like 8 minutes left. I can only deliver the high-level overview. So if you're interested in our research in this domain, please look at this published article on this slide. All right, this is our motivation. We wanted to help people who are disabled or paralyzed. So they have to rely on a wheelchair like this, right? So typically they use electric wheelchair that can be controlled by joystick. However, when you think about somebody who's completely paralyzed,